Now I have a really beautiful, nice looking guy, Frank, and he's a professor at the university in human and computer interaction. And he will talk about artificial intelligence and reality, and I think we will start with him. And after the 12 minutes talk, you have ability to ask some questions for the 6 minutes after that. Frank, thanks for having you here. It's your stage.
Yeah, thank you so much. Can you guys hear me? Everybody in the Handelskammer, can you hear me? Good. Deutsche Bank, can you hear me? Okay, looks good. So, today we live in a digital world in which artificial, natural, virtuality and reality, all these terms merge together. And therefore it's getting more and more important to clearly, conceptually define those different concepts. And if we think about natural, for example, we denote everything which became without human beings. So those are natural things. On the other hand, of the extrema, we have objects which are human-made, and all this is considered as being artificially. And actually there is no clear distinction between the both. So typically when you look around here in the city, you see stones, for example. You would consider them as natural objects, but as you can see, they are human-made in terms of buildings, and therefore those will be considered as artificially objects. And that means we have actually a continuum of real, natural physicality and the artificial world on the other side. And in between there is this mixture of objects being natural as well as artificially. And in my talk, I would like to discuss a little bit how humans made artificial objects either as intelligent or as reality. So we try to reproduce somehow the world around us as well as human intelligence. And I would like to start with intelligence first. The problem is there is no clear distinction and definition of intelligence. So typically we think about mathematical intelligence, but there are also other aspects like emotional intelligence, spatial intelligence, or linguistic intelligence. And when we talk about artificial intelligence, the roots date back to a very important summer school which was performed around 1956. And here you see some of the people who at that time were thinking about what would be an artificial intelligence. And they define artificial intelligence as human intelligence simulated by machines. And this is a very important distinction. When we talk about artificial intelligence, those is not intelligence per se. It's always some sort of a machine or technique which try only to simulate human intelligence. They are not intelligent by themselves, they just simulate this. And Alan Turing was one of the first persons thinking about how can we then control or measure if something is intelligent. And he proposed the so-called imitation game. The idea of this imitation game is illustrated here. So the idea is a human person is communicating with a machine and with a human, and if the machine is good enough to trick the human, to make the human believe that the machine is actually a human, then it has passed the so-called Turing test, meaning it was able to simulate human intelligence. And the interesting thing is that in order to simulate human intelligence, you don't have to be perfect as a machine. Actually, you have to be imperfect. To pass the Turing test, it means you also have to replicate some non-intelligent behavior of humans. And here is one example, and maybe I can have some sound here from the TV. So maybe you've heard about this. This is Google Duplex, for example, which tries to simulate human speech synthesis. And here's one example of a phone call between a real human user on the right side.
Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
So what you have heard here on the left side was Google Duplex, and you've heard that there were some things which you typically wouldn't hear by a machine. So there are some delays or this yeah, so this is something that we wouldn't expect from an intelligent system. And it's really interesting in this video how it takes like 500 milliseconds before the people get this and start to laugh that this machine is kind of simulating this human behavior. Since the 50s, we have made a large progress in machine learning. So starting from artificial intelligence with very symbolic, rule-based, logic-based programming. So you have something like if X, then Y, otherwise Z. Then later in machine learning, we started to look for patterns and features in the data by itself. And finally, deep learning is doing that with multiple layers. And due to these advancements, we were able to develop systems which no human can, for example, beat in chess anymore. Later, we had the same progress in more complex situations like Jeopardy or Go. And as you see nowadays, we have more and more fields like autonomous driving in which artificial intelligence is making huge progress. So coming to the other term, reality. And here we talk about the idea again to simulate reality. And this is typically done with virtual reality technologies, which allow users to explore in an immersive way an artificial environment. And those ideas also date back to the 60s. And here is a video, original footage of the first VR system. What you see here is Ivan Sutherland, who created the first so-called augmented reality display. And you see this user, they're moving around and exploring a very simple artificial scene, which is just this wired frame cube as illustrated here. And also virtual reality has made a huge progress within the last 50 years or so. And nowadays we talk about the smartphone era of virtual reality, in which all the advancements that we observed in the smartphone market now enter also the virtual reality market. And if we see the connections between the smartphone market and also virtual reality, we can see that the first commercial product of a smartphone was the IBM Simon back in the 90s. And it took about 20 years until smartphones like the iPhone made this computing paradigm really ubiquitous. And the real revolution came later with the App Store. So this was really revolutionizing the smartphone market. If we take a same look at the virtual reality market, we see that the first iPhone was actually a head-mounted display back in the 90s by the company VPL, owned by Jaron Lanier. And again, it took a couple of years, and nowadays, just 3 weeks ago, we had the Oculus Quest. And the Oculus Quest is really a game changer in this market of virtual reality. And you can really say that the IBM was corresponding to something like the VPL iPhone, and nowadays the Oculus Quest I would consider as the similar device as the Apple iPhone. And so you see now with the next software or applications on these devices, we will probably observe the same revolution in terms of how we interact with machines as we have seen in the smartphone market. And what you see is from technology to technology, the way how we interact with computers drastically changed. So on the left side, you see in the 60s, we had command line interfaces. Then we moved with a mouse and keyboard to graphical user interfaces. And with a smartphone, we moved to so-called natural user interfaces. And now with the new devices, like virtual reality, augmented reality, we enter a next paradigm of human-computer interaction, which we called smart user interfaces or spatial user interfaces. And what we observe from paradigm to paradigm, it gets easier for the user, for example, to fulfill their goals. It's also easier to learn the interfaces. And also the usability from paradigm to paradigm improves, and also the overall user experience. And the interesting thing is now to bring these both worlds together, so AI and human-computer interaction and virtual reality. And I would just to give you one example how this could look like if we think about intelligent artificial realities. And typically one super example of how these both worlds come together is in the area of intelligent artificial agents. We know them from science fiction, cinematography or literature, and nowadays we start to build those kind of intelligent agents or intelligent avatars. And here are a couple of videos from my group in which we try to make humans as realistic as possible. And this is the kind of state of the art that we can get nowadays. Those are not really like fully 100% realistically looking, but you can use them for a lot of applications. And humans react to these agents and avatars in a very similar way as we react to real-world persons. And that's why you can actually use them, for example, in psychological studies, or you can do some simulations with those humans and gain really some insights also for the real world. And then at the same time, it's not really limited to purely virtual agents. Those agents can also be physically, like robots, for example, as illustrated here. And on the top left, for example, you see one of my PhD students interacting with a real robot arm, but having at the same time a digital twin of this arm. And now you can do some simulation with this virtual arm and look how the arm would grab, for example, objects, and then you can at some point confirm, and then the real robot would, for example, perform the actions. Or on the upper right side, you see a telepresence setup in which you have like a pen controller, which somewhere else on the earth controls like a real robot, for example. So how will this evolve, the area of virtual reality? I told you about the Turing test, and there is a small twist of this Turing test called the graphics Turing test. I'm wondering how many of you have heard about the graphics Turing test? I see one arm. So the idea is, or the question, how can we develop a virtual reality or virtual objects which get indistinguishable from real-world objects? And actually we have this already. So if you think about a blockbuster that you watch in the cinemas, typically you don't know which parts of the movie are computer generated and which one are kind of real captured objects. The real challenge is here to do this in real time. So you have to render virtual objects 60 times per second. So think about a computer game. Think about a computer game in which you cannot tell if this is a computer generated game or if this is like a real captured scene from real objects. And based on the exponential advancements that we have in computer science and in technology development, those graphics Turing tests will be solved probably in 5 years from now. So in 5 years, you will play computer games in which you cannot tell if this is computer generated or if this is real. So realistic those virtual objects will look like. Here's one project that we performed years ago. On the right side, you see a real physical teapot. On the left side, you see a computer-generated teapot. If this Turing test is passed, we will not be able to distinguish between both anymore. Just to give you a hint how this looks like. So here's an example of a computer game, like 15 or 20 years ago almost, and you can see how the exponential advancements within the last 20 years also improve the graphical quality. And this is an exponential curve, so Lara Croft nowadays look like this, as you can see on the left side. And it gets pretty clear that with the advancement in this technology, at some point, like 5 years from now, we will not be able to distinguish between real and virtual from a graphical perspective anymore. And also the form factors of this display will get smaller and smaller and will eventually shrink down, for example, to a contact lens. And all the big players like Google, Apple, Facebook, they filled already their patents in intelligent contact lenses. And that means at some point we will also have a transition from smartphones towards smart glasses. And we can actually observe this for the first time. So this is a graph showing the shipments, and you see that for the first time in the last 10 years, shipments of smartphones goes down. So we are on the border of getting to the next paradigm. And I talked about the physical reality and the virtual reality and this continuum, that you have objects which are virtual and real, and the same applies with intelligence. So you can see on the left side human intelligence and on the right side artificial intelligence. And I just want to emphasize here that the endpoints are just a point. In between, you have a much wider variety of applications that you can use. And therefore, it's really important to not focus only on artificial intelligence or only on human intelligence or only on reality or only on virtuality. The big advantage of those technologies is bring this together in some sort of mixed intelligence or mixed reality environments. So thank you so much for your attention.
Just in time. Thank you, Frank. I got a water for you.
Thanks.
Thank you for your talk. And now we have 6 minutes, the Q&A session. I will start the timer, and if you have some questions, feel free to ask. Any questions? No questions?
Then I would have 6 more minutes to talk.
Yep.
Okay.
Hi. Why is the Turing test still so famous? Because it says it has to mimic a human being, but that's a rather complex thing, and it actually doesn't define artificial intelligence. So why does it have to be human, and why is that test still famous?
Yeah, I mean, the test is pretty old, and since 20 years or so, there is a prize which people give to that. It's called the Loebner Prize, but this prize hasn't been solved yet. So no machine has yet passed the Turing test. The Loebner Prize itself has 3 distinctions. The first one is really like passing that, so you will not be able to distinguish if this is a real human or not. But the second one, like the second prize, is you get as close as possible to this. Yeah, so they give the prize, but no machine has ever passed the test so far. So probably it's something like the Holy Grail. Yeah? So you want to develop a machine from which you cannot tell if this is a human or not. And I totally agree, it's not like the end point of artificial reality, because at some point you don't want to just mimic something which is not like super intelligent. We humans are not super intelligent. But it's still a very challenging point how you can mimic this behavior. So if you think, for example, performing calculations. Machines are very good in performing calculations, much better than all we humans are. But this would be something that we wouldn't really consider as a human behavior if you're like super good in computing. And that's why for some parts it's just easier to beat the human in certain things like chess or Jeopardy or computing, but on the other hand, it's a more challenging task to simulate a human. And that's why I think that researchers are really interested in that, because it's just more challenging at some point. And of course, if we pass the test, that means we can use those artificial intelligence as coaches, as therapists, as people, assistants with which we can just talk. And we do that actually at home if you think about like Amazon Echo or Google Now. So we have these kind of assistants with which we communicate, but at some point we always get to this border in which they frustrate us because they are not reaching at least human intelligence that we have a decent conversation with them.
Any questions?
How close are we to pass the Turing test?
That's a very good question. I think like 10 years or so, it is told that we are really, really close. Yeah? And the Turing test itself, I mean, you don't have to pass it like 100% of the time. So you have like a usual experiment in which you have like 10 people communicating, and at some point, after 5 minutes or so, they have to guess which of the two communication partners is the real human. And of course, they are able to trick parts of the participants, but not in a reliable way that you have to at least 75% of all the people communicating with both just have to guess, yeah, and they have no idea which is true. So that's a really good question. I think, for example, Google Duplex, the video which I showed to you, there are a lot of communications already done in the US, so Google Duplex is used there very, very often. And I'm pretty sure that a lot of people talking to Google Duplex are not aware that it's a machine. So in this respect, you might consider maybe we are on the border of passing that and we're getting closer to that. But I'm pretty sure it will really take long until a very clever person can be tricked by the Turing test, because you can ask very decent questions and trick questions which are really hard for a computer to interpret. So I would say we are like, probably a lot of people can be tricked, but you have always the possibility for a really long time to ask these trick questions, which computers really will probably not be able to simulate the human intelligence.
More questions?
Yes, so lately we are talking a lot about autonomous systems, autonomous cars, etc. So, but, well, if you go back to the definition of the word autonomous, then it's questionable if you can call a system autonomous. What is your opinion on this?
Yeah, so typically all autonomous systems, even if we say they take decisions by themselves, at some point somebody has programmed their behavior. In the past, it was in a very symbolic way. So that means you really clearly, descriptively define what a machine should do. Like if the light is red, then do something like this. But this point of if the light is red, this is something that the machine now starts to interpret. Yeah, it's not a sensor which is communicated. It uses other sensors like cameras, for example, and based on those information, the machine has to interpret. So in this respect, you are right. The machines that we have nowadays don't really make like fully autonomous decisions. All those decisions have been programmed at some point. And even the former CEO of Google, Eric Schmidt, who was here in Hamburg like 1 or 2 months ago, he gave a talk and we were discussing with him, and he said that still 80% of all algorithms running on Google machines are very much symbolic AI, so very descriptive, if blah, 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 then do this. Whereas only 20% is really using all the hype around deep learning or deep neural network or machine learning, etc. So that's why we are really far away from machines which originally learned by themselves without any human telling them what to do, so that they would actually be at some point autonomous systems. So nowadays we have autonomous systems which make decisions, but they have been programmed at some point always by a human being.
Okay, 30 seconds left. Anyone want to ask?
One short question. What do you think about autonomous general intelligence, like we heard yesterday? What prognosis, in which years do we have such thing like autonomous general intelligence?
Yeah, so strong AI is another word for this. This is something which is so far away from what we think about that it will probably take decades until we reach such a status. So nowadays, every AI that we have is essentially based on weak AI, and I think that's good for now.
Perfect. Thank you, Frank.
Yeah, thank you so much.
Will you be around here the next minutes? And okay, if there are more questions, Frank is here. You can talk to him. Now we have a short break for 6 minutes when we will see Martin Jung on stage, and he will talk about how to boost for startup and innovation ecosystems. And I will be back, I think, what is it, 10:30.